Okay, we've been given this question. If it's given that a and b are real numbers satisfying a cubed positive b cubed positive 3ab is equal to 1. If a positive b is less than 0, we are expected to evaluate this quantity. Now, there are two important things we need to do. We need to handle this a positive b, and then we need to handle this. So there are two actions that are required to execute this question successfully. So foremost, what I wish to do is I will handle the first part, satisfying. Okay, so given that a comma b element of R such that a cubed positive b cubed positive 3ab is equal to 1. Now we know that a cubed positive b cubed can be rewritten as a positive b times a squared negative ab positive b squared, isn't it? So in place of this I will substitute this. So I'll take this as 1. So therefore 1 can be rewritten as a positive b multiplied with a squared negative ab positive b squared positive 3ab is equal to 1. Now what we can do is probably we can club these two together. So this is a positive b of a squared positive b squared negative ab positive 3ab is equal to 1. So I want to express a squared positive b squared as a positive b the whole squared. I will get a 2ab, right? So if I want to have a negative ab there, I should have a 3ab here, okay, because 2ab and negative 3ab will produce negative ab, so followed by 3ab is equal to 1. Okay, fair enough. Now what I would like to do is I would like to assign let a positive be equal to some x. So if I were to take this as 2, therefore 2 can be rewritten as x times x squared negative 3ab positive 3ab is equal to 1. Distribute x, you get x cubed negative 3 times of x ab positive 3ab is equal to 1. Now I will bring this 1 to the other end. You will have x cubed negative 1, I'm going to write it as 1 cubed, followed by positive, okay, I will write it as negative 3 times xab positive 3ab is equal to 0. Now these two can be clubbed, okay, x cubed negative 1 cubed is a cubed negative b cubed, which is going to be x negative 1, right, followed by x squared positive x positive 1. If you expand this, you will get this. So x into x squared is x cubed and x, right, and then you have a, okay, let me just check that off. X into x is, x into x squared is x cubed, and then you have an x squared, and then you have an x and a negative x squared, and then you have a negative x and a negative 1. So positive negative negative positive giving us x cubed negative 1. So fair enough. And I need to produce that x again, right? So I will take ab 3ab out. If I were to take 3ab out, I will have x here. X times negative 3ab will give me this quantity, negative 3 times xab, and I need to get a positive ab there, so I will place a negative 1. So x negative 1 is again common, I can take that out. I will have x squared positive x positive 1 followed by negative 3ab is equal to 0. From here x negative 1 is equal to 0, or x squared positive x positive 1 negative 3ab is equal to 0. Now this means x is equal to 1, but x is equal to a positive b. So this in turn means a positive b is equal to 1, which in turn means a positive b is greater than 0. But we don't need this. Why? Because if a positive b is less than 0, then we have to evaluate this quantity. So obviously we have to find out the other side. Okay, we have to check the other side. We are not sure if we are going to get a positive b is less than 0. We have to check. Okay, so now we have this system, right? So let me go back, or I will say turn the next slide. So we got we now consider x squared positive x positive 1 negative 3ab is equal to 0. We'll be considering this. Now since x is equal to a positive b, I am going to revert back everything. So you have a positive b whole square positive a positive b negative 1 negative 3ab is equal to 0. This is what we have got. Okay, we are just reverting everything back to the value that we have just assigned, a positive b. Now the question is, we will have to perform some alterations, right? So if I were to expand this, I get a squared positive b squared positive 2ab. I already have a there, a b there, a negative 1 and a negative 3ab is equal to 0. So I add these two together. You have a squared positive b squared and negative ab and a positive b, and you have is a positive 1, not negative 1. So this is positive 1. Okay, so this is what you got as a squared positive b squared positive of negative 1 squared negative ab negative a of negative 1 negative b of negative 1 is equal to 0. Now this means you have a squared positive b squared positive of negative 1 squared is equal to, you can take everything to the other side, you get ab positive a positive b. Now this is very similar to our known equation x squared positive y squared positive z squared negative xy negative yz negative zx is equal to 0, which means x squared positive y squared positive z squared is equal to xy positive yz positive zx, which means x should be equal to y should be equal to z. Okay, so by this we have a is equal to b is equal to negative 1. So which means a positive b will be equal to negative 1 added with negative 1, which is nothing but negative 2, which is less than 0. So for sure we are able to produce, or we are able to get a added with b quantity which is less than 0. Okay, so our a positive b is equal to negative 2. But what is the parent question? The parent question wants us to find this sum. So I'm going to take this as 1. Hence 1 can be rewritten as a positive b sigma n is equal to 1 to 100. Now we have this n positive 1, right? So I'm going to write this n positive 1 factorial as n factorial times n positive 1. Okay, divided by, and you have this n positive 1 factorial. So n factorial times n positive 1 positive n factorial. So this is further equal to a positive b sigma n is equal to 1 to 100. Now I can take n factorial out, right? So I would get 1 positive n positive 1, and over here you have n factorial times n positive 1. So these two can be cancelled, giving me a positive b sigma n is equal to 1 to 100 n positive 1 divided by, this is n positive 1 positive 1, so this is going to be n positive 2. So this is what I've got. So now what I wish to do is I will have to perform some small manipulation, okay, in this case. So what I wish to do is I would like to rewrite this as 1 negative 1 over n positive 2. Can I do that? I will get n positive 2 minus 1, so I'll get the numerator. Okay, fair enough. N is equal to 1 to 100. You have a positive b. A positive b, we have already got it. I don't want to substitute it as of now, so let me retain it as it is. So this is equal to a positive b sigma n is equal to 1 to 100. We just got this 1 negative 1 over n positive 2. So this is equal to a positive b of, now you can distribute the sigma, so n is equal to 1 to 100 negative sigma n is equal to 1 to 100 1 over n positive 2. Okay, now this is going to be 100, so a positive b times 100 negative, now this n is equal to 1, right? So we are going to start with 3 and 4 plus etc. It will go all the way to 102. Now what I wish to do is I want to have a 1 over 2 here and a 1 here. So I will have to subtract that 1 over 2 and that 1. You follow me? I'm adding 1 and 1 over 2. I'm taking away 1 and 1 over 2. So this is equal to a positive b 100 minus, now this entire term can be written as 1 positive 1 over 2 plus etc 1 over 1 over 2, and I have to bring this negative 1 over 2 negative 1 out. So if I were to bring that term out, that is going to be having a negative sign here, and you have a positive there, so 1 over 2 positive 1, because this negative is going to be hitting this negative sign, I get a positive 1 over 2, negative hitting negative 1 will get a positive 1. Okay, fair enough. So this is how the system now looks. Now this is nothing but an harmonic series. Okay, H102. So you have a negative sign before that. I'll show you how to calculate this. Okay, so this is equal to a positive b 100 minus H102 positive 3 over 2. So this is what we have got. So now if we can add up these two together, now I will substitute a positive b is negative 2, right? Negative 2 I'll substitute because we just got a positive b, right? We got the value. So negative 2, this is going to be 100 positive 3 over 2 negative H102. So the negative 2, this is 200 203 divided by 2 negative H102. Now H102 has a value. Okay, that value H102 is given by ln 102 plus gamma. Okay, gamma. Now this gamma which we see here is called as the Euler Mascheroni constant. Okay, Cheroni. Okay, Mascheroni constant, and this constant is approximately 0.5772. So we take this value, and ln 102 has an approximate value of 4.625. So we have 4.625 added with 0.5772. Okay, so this is going to give me 2, 12, 10, 12, 1, 5.2022. Okay, so this is going to be equal to negative 2 times 203 divided by 2, and negative positive 2 times of 5.2022. 2 gets cancelled, and over here you get negative 203 and positive, you multiply, you get 2 2s are 4, 2 2s are 4, 2 0, 2 times 0 is 0, 2 2s are 4 and 10. So this is the value you get, 10.1234. So 1 2 3 4. Okay, fair enough. So from 203 you take away 10.4044, right? This is 0 0 0 0. So we will have to make the subtraction. If we were to make the subtraction, 10 take away 4, you get 6, you have 9, you get 5, you have 9, you get you have to bring that 9 down, right? 10, 9, you have a 10 here, 6, 9, it will you will get a 5 there, and this is going to be 9 brought down, and 9 is there. From 9 you take away 4, you get a 5 there. So this is what you're getting. So this is already a 2 there, you bring the 2 down, right? You already borrowed, you have a 2 there, you bring it down, and you borrow 1 there, 10, from 10 you take away 1, you get 9, and this is the value you're getting, but it's a negative sign. Okay, so this is approximately negative 192.5956. This is the value you have got for this sum. Okay, so please like, share and subscribe. Thank you everybody.